The next learning objective of this module is the relational database management system and how to create it using normalization. So when we deal with data in the form of table, what we are generally familiar with is a flat file. A flat file is a single table. It contains a lot of rows and columns, and often it looks structured, but it may have redundancies in it that are just making it very complicated. For example, if we look at this example table, we can see that the columns item and quantity appear multiple times because for each row there may be multiple values of item. For example, in case of Paul Smith, there are multiple items. So in order to handle that, we end up creating multiple attributes. What ends up happening is that we have a lot of empty fields or empty values, which end up taking unnecessary disk space on the computer, but they are just holding blank values. This flat file can be converted into a relational database. We know a database is a structured a structured way of handling data in a computer. A relational database is a database where we have multiple tables related to each other. So a relational database management system is a computer program specialized to organize, manage, access, and update a relational database. And a relational database is a database plus a schema. We learned about database, we also learned about schema. And if we have multiple tables with some schema, that becomes a relational database. Here's an example of two tables. We have students table that it tells us the student ID and their name. And we have a second table, which is activities table, which gives the ID of the student and what activities do they do. So clearly we have two different tables, but there is a relation between them. So the database has two tables, students and activities, and the schema is that the student's attribute ID is related to the activities attribute ID. So this relationship can be represented with a schema, and database and schema together form a relational database. So when we look at a flat file versus a relational database, we can see some advantages. If we look at the flat file, we can see in this case it's a name, department, boss, and phone. We see that Smith, Jones, and Lennon are all in sales department. They have exactly the same boss who has the same phone number. Similarly, Said and Mosak or Masak, they are both in transport department, same boss and same phone number. So we see a lot of redundancy here of the data. Now suppose we split this into two tables that are related through department in the schema. Then we have saved some disk storage. So in this case, the first table called the staff table gives the names of the people and their departments, and a second table which provides the list of the departments and the bosses that run them. So this way now these bosses and their phone numbers only appear once in a different table. So hopefully this example shows the advantage of relational database. This is a small example, but then when we're talking about millions of records and hundreds of columns, then this can have good payoff in saving the disk space as well as saving processing time when we are searching for different entries. A relational database can relate different tables. So here is another example. We have forests, trails, characteristics of different trails and the recreational features in the different trails. Now, if we put all of this into a single table, that would be a flat table, and it will have a lot of blanks. But we can see that in forests and trails, we have each forest, there are two forests, and each forest have some trails in it. And those two are related through separate two tables through a relating column called forest ID that appears in both. Similarly, all trails have some characteristics, which are some features in it and their difficulty level. So again, the trail name relates these two tables. The characteristics are related to the recreational features that are available. So feature vista means that this trail has a scenic overlook. You can do photography here and you can do viewing here. So again, because this feature appears in multiple trails, we have a separate table called what are the recreational features, and they are linked to the characteristics through the column feature. These tables can be joined together to form a flat file, which we will learn later. But at this point, how are these related is represented through schema, which is basically an entity relation diagram, how these entities are related to each other. And for this particular example, the entities are forests, trails, characteristics, and recreational features, and they are related through these arrows. So forest ID of forests is related to the forest ID of trails. The trail name of trails is related to trail name in characteristics. The feature in characteristics is related to feature in recreational features. So this is a representation, also called the ER diagram or entity relation diagram, which represents the schema of this relational database. So when we talk about relation, then we define a foreign key and a primary key. So if we look at these two tables from our previous example, then a foreign key is a field or attribute in a table that uniquely identifies a row in another table. So this is a foreign key for forests table. So 1 identifies the first row in the forest table, whereas 2 identifies in the second row in the table, but these exist in a trails table. And this is the source of this relationship. The foreign key in one table relates to the primary key in the other table. The primary key is also the table with primary key is also called the parent table, and the table with the foreign key is also called the child table. Then when we talk about these relations between different tables, there are 4 types of relationships. One-to-one is straightforward, that each entry or each value in one attribute corresponds to only a single unique value in the other attribute. But this can also be one-to-many. For example, if we look at the relationship from forests to trails, then a single entry in the second row 2 corresponds to 3 rows in the trails table. Clearly, each forest can have multiple trails. So this is a one-to-many relation. Likewise, we can have many-to-one relation. And many-to-one relation is basically just inverse of the one-to-many relation. So we can create that the relations from trail to forest is many-to-one. But we can also have many-to-many relations. Although these exist, but they basically relate multiple features or multiple values in one attribute to multiple values in the second attribute. For example, in this case, if we look at the Bryson's knob, then the Bryson's knob is related to 2 features. And likewise, if we look at the features, the Vista feature is related to 2 trail names. So there's many-to-many relation many on this side are related to many on the other side. This leads us to an interesting concept in databases called the functional dependency. A functional dependency is a relationship that exists when an attribute or a set of attributes uniquely determines another attribute or set of attributes. For example, in this case, if we know the name of the student, we can tell their ID. Or if we know the ID of the student, we can tell their last name. Or if we know the ID of the student, we can tell what their status is or what their credits are. So these are functional relationships. And so they're kind of similar to the idea of function in math, where the arrow indicates a relationship between some independent value and a dependent value. So in this case, if student ID is known, then last name can be uniquely determined. And that's an important feature, that it has to be uniquely determinable. Now, here's an example of functional dependency. If we look at this table, land records table, then we can see that if we know the parcel ID, we can tell who the alderman is and which township it is in, its ID, and the name of the township. Likewise, if we know the township ID, we can tell which the township name and the township address. If we know the owner ID, we can tell the owner name and owner address. So these are all the functional relationships. These can go from a single attribute to a set of multiple attributes, or a set of multiple attributes to a set of multiple attributes. And you should be able to see that there exists some multiple set of attributes that are related or functionally dependent on multiple set of attributes. So the other type of dependency is called transitive dependency. And as the name indicates, there is a transition from one to another attribute. So if A is functionally dependent on B and B is functionally dependent on C, then A is functionally dependent on C. So this is basically the transitive property that you may have seen in math as well. So as an example, if we know the employee ID, we can tell their department ID. And if we know the department ID, we can tell the department name. So through this transitive, if we know the employee ID, we should be able to tell the department name in which that employee works. So both functional dependencies and transitive dependencies exist in tables, and they play a key role in the normalization process that is used to create relational databases. So the database normalization is a process of minimizing redundancy from a table or set of tables in a database. Normal forms are used to eliminate or reduce redundancy in databases. There are three normal forms. They're called 1NF, 2NF, and 3NF, meaning first normal form, second normal form, and third normal form. The first normal form is a form which does not contain any composite or multi-valued attributes. A second normal form is a first normal form plus an additional constraint that it contains a single attribute as a primary key. And then the third normal form is a second normal form with an additional condition that it does not contain any transitive dependencies. So it may sound complicated, but we can look at some examples to understand this. Here is a flat file, and clearly you can see it's a movie rental table. So Janet Jones rented multiple movies, Pirates of the Caribbean and Clash of the Titans. In this case, Janet Jones' row is multi-valued for movies rented, and this is not allowed in a relational database. This is a flat file and it needs to be converted to first normal form. So what we do is we take each multi-valued attribute and split it into multiple rows. So for Janet Jones, we end up creating two rows, one with each movie. And this way we achieve what we call the 1NF, or first normal form. We do this for all the multi-valued rows. Similarly, if we go to the second normal form, then we have we must have a primary key attribute. So in this case, if we look at these this table, we don't have a single attribute for as a key. If we try to find a row with the full name, then there are two rows that will end up as identified if we choose Janet Jones. So this table is not in the 2NF form. In order to do that, we can split this table into two, and introduce a primary key ourselves, and then create a second table which provides the rest of the information. So this could be called a member table, where we have three members: Janet Jones, Robert Phil, and a second Robert Phil with a different address. And that's why we have a primary key now that identifies all of these three customers separately. And then another table that tells us which member has rented which movie. And this would be considered a 2NF in the normalization process. Likewise, the third normal form is the one that does not have transitive dependency. So if we look at this table, then the name of the member can be found from the member ID, and then the salutation can be found from the member name. So all the, for example, male members would have Mr. and female members will have Miss salutation. And if that is a transitive property, it can be removed by further splitting this table. So we could have a new table called the salutation table, which lists all the salutations and gives them a unique primary ID. And then there could be a relation between this table and the original table by introducing the salutation ID. And this way we have removed the transitive dependency that existed in this table. And by doing that process, we have converted the table into 3NF, or third normal form. So here's another example. Let's say we have a list of students, their states, and their countries. And as you can see, if we know the name of the student, we know the state. And if we know the state, we know the country. But Nevada and USA appear twice. Punjab, India appear twice. So we can split this into two tables. One about the students and their states, and a second table which relates state to which country they belong to. Here's another example from your book. So we have land records table, and in this table we have a lot of redundancy and multi-valued rows. For example, Johnson or the parcel 2303 had multiple owners. So there is Devlin, Yamain, and Prestovic. But this redundancy or multi-valuedness should not exist in the 1NF. And so for all of these redundancies, we create a separate row and we get the 1NF in the normalization process. Now, if we look at this table, we do not have a single attribute primary key. If we want to uniquely find a row, we need to use multiple attributes to uniquely identify a row. So this does not qualify for 2NF. In order to convert it into 2NF, we split it into three tables, and now you can see that there can be a land records table 1, which has parcel ID, and that could be the unique primary single attribute primary key. Similarly, we could have the owner ID, where the owners table, where the owner ID would be the single attribute primary key, and then these two could be related through a third table, which um, corresponds to our main table in a way. Now, if we look at this table 1, we can see some transitive dependencies. If we know the township ID, then we know the township name. If we know the township name, we know the town hall address. So there's a transitive relationship here. And in order to remove this, we can again split this table into two tables, where the first table relates the parcel ID with township ID, and then all the township IDs are listed in the a separate table providing the other attributes of individual townships. So hopefully this process shows how we take a flat table which looked like this, and we created 4 tables, and there's a schema that goes with this, that the parcel ID is related to this parcel ID, the owner ID is related over here, and then the township ID is related over here. So there could be a schema that goes with this group of tables, forming a relational database.